so example 1, we're going to write a paragraph proof of the triangle angle sum theorem. We're given a triangle ABC. We need to prove that the angles in the triangle 1, 2, and 3 add up to 180. As with all proofs, if we have a picture drawn and we're referring to angles as angle 1, 2, and 3, or angle ABC, whatever, if you draw the picture, you can be a little more abbreviated in what you write, save some writing. So always include a picture in your proof. It makes life easier. So my thoughts on this problem, if you recall the construction we did yesterday, which we had a line and we had a point off the line, we constructed the parallel line through that point. That's kind of just an idea of what Theorem 210 states, which says, through a point not on a line, there is one and only one line parallel to the given line. So if you look at the picture with a triangle has 3 vertices. 2 vertices lie on one line, the third vertex has to be off of that line. So if I just were to pretend, some stuff going on in here, that AB lies on some line here, and it actually touches AB. This is the line that AB lies on, this red line. And point C is a point not on that line. According to Theorem 210, there's only one line parallel through AB. So the first thing I'm going to do is I'm going to draw that line. All right. So if I'm doing a proof that doesn't include a line that I need, I'm going to draw the line in there, and if I need to justify why I did it, I'm going to. And just drawing some random line doesn't matter. Like if I want to draw a transverse, it doesn't matter what transversal I draw. But if I want to draw a line that's exactly parallel to AB, I have to explain myself. I'm allowed to do this because of whatever. In this case, I'm using Theorem 210. So I know that this line here is going to be parallel to this line here. And I'm just going to put another point on. I'm just going to put a point D up here just to be able to name that line DC. All right. So again, I'm going to put whatever symbolism on my picture necessary so I can refer to things in my proof and people know what I'm talking about. All right. The other thing I'm going to do here is I'm going to add one extra angle. And if we look at the transversal in this picture, this transversal here, or the other transversal, take your pick, doesn't matter. You go BC or AC, I'm going with AC. So I'm looking at the transversal AC. The angle in my picture that I'm worried about, angle 1, relates to what other angle in the picture that's not numbered yet? DCA up there, right? So angle 1, let's call this angle 4. Those two angles are alternate interior angles. If these lines are parallel, those two angles should be congruent to one another, right? And then if I look at the other transversal, I'm running out of colors here. This transversal here, same idea. Angle 2 and let's call this angle 5 are also alternate interior angles, right? So here's my thoughts. I had to doctor up the picture a little bit here, but I've got my parallel line that exists because of Theorem 210. My transversals that are already in there, AC and CB, I don't have to extend the lines to make them transversals, but I've got my alternate interior angles there, alternate interior angles there, right? So they're congruent because the lines are parallel. I know 3, 4, and 5 add up to what?
180.
Because? Straight line has 180 degrees in it. And I know 4 equals 1 and 5 equals 2, so then 1, 2, and 3 make 180. So there's my proof thought out. Now I just got to put it to paper, or to board in this case. So here we are given triangle ABC. First step, always write the given information. Gets the brain juices flowing a little bit so we know that we got a proof starting. It gets us a little bit of correct stuff on our paper. The next thing I did was the parallel line deal, right? So by Theorem 210, and I'm fine with you writing Theorem 210. If you got your theorem sheet, I'm using the same book you guys are using, so when you say Theorem 210, I can look it up and see what it is, right? if somebody else who wasn't using this book, and you said Theorem 210, they don't know what the heck you're talking about. But again, for the sake of our community here, I'm reading out of the same book you guys are reading. Theorem 210 has words. I can see the words. That'll be sufficient. If I was writing a more formal proof, I'd want to write, since you can only draw one parallel line through a point off a given line, then, you know, you can do that. So, but Theorem 210 is sufficient here. I'm going to say, draw line DC parallel to line AB. That's what Theorem 210 says we're allowed to do, so we're going to do it. Okay. And we actually drew that in the picture, so I'm actually describing this. I'm saying draw this line. Draw this line parallel to this given line. And then I don't have to describe the transversals. AC is still a transversal, even though it's just a segment. BC is still a transversal. If I need like the corresponding angles, I have to go beyond it like that, right? But I'm doing alternate interior, so I don't really need that blue and purple line. In fact, I'm going to take those out just so they're not in the way. So even with the segment AC and the segment BC being transversals within the interior of those parallel lines, angle 1 and angle 4 are alternate interior angles. Angle 2 and 5 are also alternate interior angles. The alternate interior angle theorem says when two lines or two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay, so I'm allowed to conclude congruence. So I'm going to say by the alternate interior angles theorem, angle 1 is congruent to angle 4, and angle 2 is congruent to angle, let's just use the congruent symbol, is congruent to angle 5. So I'm not saying the words, I forgot to write the symbol. All right. So angle 1 is congruent to 4, angle 2 is congruent to 5. And then finally, I'm going to go on to equality. Okay, if I start with congruence, I can then say they're equal. Things that are congruent are equal measure. Things that are equal measure are congruent by the definition of congruent angles. So by the definition of congruent angles, measure of angle 1 equals measure of angle 4, and measure of angle 2 equals measure of angle 5. Okay. A lot of work there just to say that 1 and 4 have the same measure, 2 and 5 have the same measure, but again, that's the idea of proof. We're going through a logical sequence of hypothesis leads to conclusion to get us to the point we want to get to, which is that 2 and 5 are the same measure and 1 and 4 are the same measure. Continuing on, I'm going to use the straight line fact. DC is a straight line, 4, 3, and 5 make the straight line, so I know since, let's go with since instead of by. Since there is 180 degrees in a straight line, measure of angle 4 plus measure of angle 3 plus measure of angle 5 equals 180. And again, we already know that 1 equals 4, right? So that can be changed to 1, and 2 equals 5, so that can be changed to 2, right? And just to get the same order, I'm going to put in angle 1 plus angle 2 plus angle 3. So finally, by substitution, measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. And again, you're done with the proof when what you're trying to prove has been stated in your proof. So once you've said what it is you're trying to say, and everything you have above that backs up what you're trying to say, your proof is completed.